In the previous video on chemical kinetics, we had discussed about the rate of a reaction, average rate of reaction, instantaneous rate of reaction, etc. Now in this video, we shall discuss on the factors affecting rate of reaction, particularly the concentration. Now let us just list out the various factors which affects the rate of reaction. A lot of factors affects the rate of reaction. I'm listing out only a few. Okay, the nature of the reactant is one of the factors which affects the rate of the reaction. Alright, what type of reactant it is. Then we have the concentration of the reactant, temperature of the reaction, the temperature condition in which the reaction is being carried out, then pressure of the reactants, particularly if it is a gaseous reaction. The pressure of the gaseous reactant is important. Okay. Then if you're using a catalyst, what is the presence of a catalyst, and also the area, specific area of the catalyst also decides the rate of the reaction. Presence of inhibitors, then intensity of radiation, particularly in photochemical reactions. The intensity of radiation decides the rate of the reaction. Presence of ionizing radiation in case of radiochemical reactions, and presence of ultrasonic waves in case of solar chemical reaction, that is reactions which uses the sound energy, similar to your photochemical reaction where you use light. In solar chemical reaction you use sound as a source of energy. And also the nature of the solvent in which the reaction is being carried out, and also how the solvent interacts with the solute or the reactant. This is particularly important when you are carrying out the reaction either in aqueous media or non-aqueous media. Okay, so these are the various factors which affects the rate of a reaction. Now we shall specifically see how the rate of the reaction depends on the concentration of the reactant. Alright, now there are lots to discuss under this topic, that is dependence of reaction rate on reactant concentration. We shall slowly move forward. Now as you know that when the reactant concentration is more, the rate of the reaction increases. That is, the concentration of the reactants increases the rate of reaction. Now why is that so? It's because when more number of molecules of reactants are there, the number of collisions and the probability of their interaction increases, and hence the reaction rate increases. And also, as the time proceeds, the reaction rate decreases. Now that is because the amount of reactants decreases as time proceeds, because most of the reactants would have got converted to products. Now you would have seen in the last video a plot wherein we are plotting concentration versus time, concentration of reactant versus time. So as time proceeds, the concentration comes down, or concentration of the reactants decreases. Okay, now the dependence of reaction rate on the concentration of reactant is expressed as an equation called rate equation or rate law. Okay, so rate law or rate equation gives us the relationship between reaction rate and reactant concentration under consideration. Alright, now every reaction will have a rate law, and it's easy to write the rate law and rate equation, etc. We shall see what it is. Now rate equation or rate law, we can define it as an equation which expresses the experimentally observed rate of a reaction in terms of molar concentration of the reactants. Now that is important. We are experimentally determining the rate of a reaction. Okay, so the relation between the experimentally observed rate of a reaction to the molar concentration of the reactants is the rate law or rate equation. Now, how do we write the rate law or the rate equation? We shall see. Now, consider an equation or reaction A plus B giving the product. Okay, suppose this is a general reaction. Now, the rate equation for this, we write it as rate equal to K into concentration of A to the power of X, concentration of B to the power of Y. Okay, this is the way we write the rate equation. Now, the X and Y are integers or fractions. It can even take up the value of 0. Okay, it can even be 0. We shall see that. And K is the rate constant or specific reaction rate. Okay, K is the rate constant or specific reaction rate. X and Y are integers or fractions. X and Y are determined experimentally. And that we are introducing into the rate equation or rate law. Now, when the concentration of A and concentration of B is 1, what happens? Rate will be equal to K. Rate will be equal to rate constant, isn't it? Right? When the concentration of A is equal to and concentration of B both are equal to 1, the rate will be equal to the rate constant K. Now, that is called the specific rate of the reaction. Okay, so how can we define K, the rate constant or specific reaction rate? It is K will be the rate of the reaction when the concentration of the reactant is unity. That's it. Okay, so the specific reaction rate is the rate of the reaction when the molar concentration of the reactants is unity. That is when you get rate equal to K. Okay, so that is the definition of specific reaction rate. I repeat once more, specific reaction rate is the rate of the reaction when the molar concentration of the reactants is unity. Okay, now there are a few differences between rate of reaction and specific reaction rate. Okay, now reaction rate determines or expresses the speed with which the reactant is converted to products, while specific reaction rate is only a proportionality constant in the rate law, K. And reaction rate is the rate of change of concentration of product or of reactants with time, isn't it? We have defined it in our last video. And specific reaction rate is equal to the rate when the concentration of each of the reactants is unity. The reaction rate depends on the concentration of reactants, while the rate constant or specific reaction rate is independent of the concentration of the reactants. Okay, so these are the basic difference between reaction rate and specific reaction rate. Do not get confused with the two. Okay, now reaction rate becomes equal to specific reaction rate when the molar concentration of the reactant is unity. Now, there are few examples wherein how do we write the rate law, which I have shown. Say one example is H2O2 liquid giving H2O plus half O2. The rate law is written as rate equal to K into concentration of H2O2. Okay, rate constant into concentration of the reactant. Similarly, another example, the first one was involving only one reactant. Now you have two reactants. Then you write the rate as like this. The rate law will be K into H2 into I2. Now suppose the stoichiometry is not 1. Now here you have 2NO and 1O2. the rate will be equal to K into NO2, NO to the power of 2 and O2 to the power of 1. Now, do we write the rate law for all these reactions? I mean, all the reactions involving stoichiometric constant like this? That is a question. Because what I mean is the value of X and Y in the rate law, okay, that is the power to which we are raising to the molar concentrations, should it be equal to the stoichiometric constants or stoichiometric coefficients? Let us see another example. This is the oxidation of acetaldehyde to methane and carbon monoxide. Look at the rate law. K into concentration of acetaldehyde to the power of 1.5. So this is an example which shows that X and Y can take up fractions. And also this is an example which shows that the power to which we raise the concentration terms in the rate law is not the same as stoichiometric coefficients. Another example which shows the same thing. We have 2NO2 plus F2 and the rate is given as K into concentration of NO into concentration of F2. We are not considering the stoichiometric constant coefficient 2 in the rate law. Okay, so that means the exponents in the rate law need not be the stoichiometric coefficients. Okay, it can be or it need not be. Now that is because we express the rate law and we determine the rate law experimentally. We do not write the rate law based on the equations. Okay, based on the equations of the reaction. We have to determine the rate law experimentally. And experimentally, what do we determine? We determine the X and Y terms. That is the exponents of the reaction. Now what are they? We will discuss. Okay, so the rate law is to be determined experimentally. Okay, so how do we determine the rate law or the exponents of the rate law, and what is the exponents called, etc. We shall discuss in the next class. Alright, thank you.